Assalamu alaikum friends, my name is Bilal Khan and this is my 21st video of DevOps. So in this video I am going to talk about Kubernetes. Previously the project structure was monolithic. Alright, so monolithic is an architecture in which multiple parts of an application are bundled together or combined together. Alright, so let's take a look at this. As you can see that here is a Facebook application, and inside this Facebook application there are multiple parts like login, newsfeed, story, posts, friend list, block list, Facebook ad. Alright, and these parts, as you can see, that all of them are combined together. Alright, and they are not working independently. Alright, so you can deploy it as a single application without dividing it in multiple parts. Alright, so if you made changes in any part of the application and if you want to deploy it, you will have to deploy the whole application. So these are some of the disadvantages of it. If you made changes in login, it may affect other parts of an application. Alright, so if you made changes in login or any part of the application, it may affect other parts of the application also, because they are connected together and they are not working independently. So after making changes in one part of an application, you have to deploy the whole application again to the server. Alright, I have told you that if you made changes in any part of the application and if you want to deploy it to the server, you will have to deploy the whole application. And you know that Facebook is not a simple website. It's a whole application, it's a big application, and it will take a lot of time to deploy. Alright, so now there is another architecture, that is microservices. So instead of deploying the whole application as a single component, it will divide an application into multiple components like this. Alright, as you can see that Facebook is divided into multiple parts and each of the parts is working independently. Alright, so each of the components will work independently, and by making changes in one component, it will not affect another one. Alright, because they are working independently. APIs are used to communicate between each other. Alright, although they are working independently, but if they want to communicate between each other, the APIs will help them to communicate. Alright, so these components are loosely coupled. It means that they can work independently and they can also communicate. Alright, so let's say that if every component is given 64 GB memory. Alright, there is an example that if every component of the Facebook is given 64 GB memory, then it is not useful for each component. Why? Because all of the components may not require 64 GB. Some of them may require less than 64 GB, or some of them may require more than 64 GB. It depends upon their requirements. Alright, so how to allocate the resources according to each component's need and not waste the resources. Alright, because each of the component has different requirements and we don't need to allocate the same resources to each of the component. Alright, so how to allocate the resources? So containers will solve this problem. Alright, if you do not know what is container, then please watch my Docker session, Docker tutorials. I have briefly explained what is Docker and what is container and what is the use cases of it. Alright, so containers are basically solving the problems of allocating the resources according to each component's need. It will only take the resources that are required for an application to run. Alright, in this way the components like login, post, newsfeed, etc. has no need to run on multiple servers. Alright, because one server is fulfilling the requirements of multiple containers to be run. So why do we need multiple servers? Alright, so instead there will be multiple containers inside one server that will contain multiple components like login, post, newsfeed, etc. Alright, so let's take a look at this example that here is a server, and inside this server there are multiple containers like login container, post container, friend list container and block list container. Alright, so this server has a space of 80 GB. Alright, so in this way the login container is requiring let's say 20 GB of memory. So the server will assign 20 GB of the memory from its server. Similarly, if the post is requiring let's say 50 GB of the memory, because post is requiring more. Why? Because post is uploading every second or every minute. Alright, so in this way it requires more memory than the login. So it will be assigned 50 GB from the server. Now how much space is remaining? 30 GB space is remaining. So the 20 GB space memory will be allocated to the friend list container, and the block list container will be allocated 10 GB memory. So in this way there is no need to jump to another server. Alright, we just need only one server to run all the containers. So these are some of the examples. So let's say the first example, that let's say while running an application you want to create more container. Alright, so you will enter the command to create it, and if many users came to an application, alright, for one container, if you want to create one container, it will be easy to enter the command to create it. But let's say if many users came to an application, let's say if many users logged into the Netflix, alright, and in this case you want to create more containers, so you require 1,000 more containers to create. So will you enter the command 100 times or 1,000 times to create the containers? No. Because why? It is requiring manually tasks to complete it. Alright, so you will have to manually insert the command. In this way it will be very time consuming, and if the user is waiting there for the Netflix show, the Netflix show will go away. Alright, so here is another example. Then let's say you want to create 500 containers in multiple images. Alright, will you enter the command 500 times for each image? No, because it will also take some time it will also more time to create those containers. Alright, and let's say that you created 500 containers, but you only need 100 containers. Will you delete the 400 containers one by one? No, because it is also the time consuming process. So you want to automate this process. How to automate this process? So how to control the creation, deletion of containers and automate the process? It will be with the help of Kubernetes. Alright, so Kubernetes will automate the process of creating and deleting the containers. If many users logged in at the same time for a match, then Kubernetes will monitor them and automatically create the containers. So it is going to monitor all of the users that are going to log in, and it will create the containers according to the requirements. But if the match is over and users are logged out, then Kubernetes will automatically delete those containers, because those containers are not required now. Alright, so this container process is also used in the big organizations like Amazon, Google, Facebook, Netflix, because in let's say if many people, if thousands or 100,000s of people logged in at the same time, then the server may go down. But with the help of Kubernetes, it is not going to happen. Why? Because the Kubernetes will automate the process of containers. Alright? So Kubernetes is not specific to be used only for the Docker container. So there are a lot of containers, there are a lot of types of the containers. So it is not specific to the Docker container. It is used for all the containers like container D container or Rocket containers. Alright? It supports all the containers. So let's take a look at the definition of Kubernetes. So Kubernetes is an open source container management tool. So it will manage the containers, and it's an open source, alright, which automates the container deployment. Alright, so it will automatically deploy the containers, and it will scale the containers. It means that it will increase or decrease the size of the containers, how much containers are required, or how much containers needs to be deleted. So this will manage this. Alright, and load balancing. What does it mean? So let's say there is an overload on one container and another container is free. So the Kubernetes will take some resources from the first container and give it to the free container. In this way, the resources will be distributed among different containers, and there will be no burden on one container. It schedules, runs and manages the isolated containers that are running on virtual, physical and cloud machines. So first thing you need to keep in mind that the containers will be scheduled, run and managed. Why? Because let's say that I want to create multiple containers, or 5 or 2 containers, or 3 containers, or 10 containers after 2 hours. So I will schedule those containers and it will be created after 2 hours. Alright, let's say if I want to delete 500 containers after 2 days. So those containers will be deleted after 2 days. So this is the functionality that you can schedule, run and manage the isolated containers. So in the previous video I have shown you that the containers are isolated. So they do not know what is happening outside the containers. Alright? And the containers are working virtually, physically and on the cloud machine. Alright? So it is not specific to just virtual machine or physical machine or cloud machines. No, the containers are working on virtual, physical and cloud machines. Alright? So all top cloud providers support Kubernetes, like AWS, like Google Cloud, like Azure. So these cloud providers support the Kubernetes. So let's take a look at the history of Kubernetes. So Google developed an internal system called Borg, alright, and they later named that Borg to Omega, to deploy and manage thousands of Google applications and servers on their clusters. So Google was working internally on this technology, and after some time in 2014 Google introduced Kubernetes, an open source platform written in Golang, and after that they later donated this software to the CNCF, or Cloud Native Computing Foundation. So but before, the Google was also working internally on the Kubernetes technology for their applications to run or deploy on their servers. Alright. So what is the difference between cloud computing or cloud native? So the cloud computing is basically to take the resources from the cloud or from some another place, but in terms of cloud native, it will only take the good features and qualities from the cloud and develop something from it. This is the difference between cloud computing and cloud native. So Kubernetes is also called K8s. So where does this K8s come from? So basically, you will take the first alphabet of the Kubernetes and the last alphabet of the Kubernetes, and in between all the characters will be counted and they will be written in numbers. Alright, so you can apply this formula in other long word also if you can, but I have applied this formula in the Kubernetes, and this is also called, the Kubernetes is also called with K8s. So online platforms for Kubernetes or K8s are Kubernetes Playground, Play with K8s, Play with Kubernetes Classroom. You can use this platform in your Google browser or any other browser without installing it. Alright, and you can also use the Kubernetes services inside the cloud services, like Google Kubernetes services, Azure Kubernetes services, Amazon Elastic Kubernetes services, and you can install the software inside your machine, and the software will be Minikube and KubeADM. Alright. So problems with scaling up the containers. So basically the containers cannot communicate with each other. I have shown you that the containers are working in an isolated environment, so they do not have the functionality to scale up. So that's why, because they cannot communicate with each other. Alright. And the auto scaling and the load balancing was not possible. Alright. The auto scaling means to increase or decrease the size of the containers, and the load balancing to distribute the resources of the containers was not possible to scale up the containers, and containers had to be managed carefully. So these are the problems that basically allowed the Kubernetes to work on. Alright. So features of Kubernetes. So the first feature is the orchestration. So clustering of any number of containers running on different networks. Alright. So clustering or grouping or bundling of any number of containers running on different networks. Let's say that if one container is running physically, one container is running virtually, and one is running on cloud. So these are three containers that are running on different spaces, right? One is running physically, one is running virtually, one is running on cloud. They are running on multiple machines, on multiple servers. So these three containers can be combined together to form a cluster. All right, and it means that it supports hybrid cloud. So hybrid cloud is to combine multiple containers from different spaces and combine them to form a cluster. This is called the hybrid cloud. And auto-scaling, so it supports vertical and horizontal scaling. I have shown you that auto-scaling is to increase or decrease the size of the containers, but auto-scaling itself is divided in two parts. The first part is the vertical and the second part is the horizontal scaling. So let's take a look at the vertical scaling. So here you can see that it's the container which contains a 2 GB space of resources. All right, and if you want to vertically scale it up, then you can increase the size of this container with 2 GB more, and now it will be 4 GB. Now you didn't add another container. Instead, you just increase the size of this container. All right. But if you want to horizontally scale this container, let's say this is a container of 2 GB size. If you want to horizontally scale this up, you will add another container. All right. So in the vertical scaling, you just increase the size of the container, but in the horizontal scaling, you add another container. All right. So you need to keep this in mind that horizontal scaling is preferable. Why? Because there is a limitation of increasing the size of the container. You cannot increase the size of the container at some limit. All right. But you can add the containers without any limit. All right. So load balancing. The requests or any kind of load should be equally distributed among containers. I have shown you before that if, let's say, one container contains a lot of resources, but another container is free. So the Kubernetes will take some resources from the first container and give it to the free containers. So in this way, the load will be distributed. Platform independent. It supports cloud, virtual, and physical environments. All right. So the Kubernetes can be run on cloud, virtual, and physical environments. Fault tolerance. It will monitor the pod. So what does this pod mean? So pod is a smallest unit of the Kubernetes. Inside this pod, there is a container. Inside a container, there are applications running. All right. So why this pod came into picture? Basically, there are a lot of containers working on. Like Docker has different type of container which has different settings. Similarly, container D has different kind of containers which has different kind of settings. So there are different kind of containers with different settings. So the container Kubernetes has created a layer. Inside this layer, there are multiple containers with multiple settings. All right. So it will monitor the Kubernetes will monitor the pod, and if this pod is failed, it will automatically create the new pod. All right. Rollback. So it will help you to go to the next and previous version of an application. If you want to go to the next or the previous version of an application, the Kubernetes has a feature to go with the help of this rollback feature. And health monitoring of containers. So it will continuously monitor the health of containers. All right. So if one container is failed, then it will create a new one. And the batch execution is another feature of the Kubernetes. You will give commands in YAML. What does it mean by YAML? So YAML is a markup language. You can also give the commands in JSON file also. I have created a separate videos of it. Of the YAML. If you want to know what is YAML and how you can write the commands in YAML, you can watch those videos. All right. The execution can be done all at once. All right. It means that if you give the command, all the commands will be executed all at once, or all the commands will be executed sequentially. Means first do this and then do that and then do that and so on. All right. And the commands can be executed parallelly. It means that run multiple executions at the same time. All right. Now let's take a look at the architecture of the Kubernetes. I'm going to make a separate video of the architecture of Kubernetes, but let's take a look at a small architecture of this Kubernetes. Here is a cluster, alright. Inside this cluster there are multiple nodes, master nodes, child nodes, pods, and inside the pods there are containers and applications. Alright. So here is a master node, alright. After that, these are the child nodes. Node 1, node 2, and these nodes are connected with this master node. After that, one thing you need to keep in mind, and that is the cluster has 3 types. Alright, the first type is that one master will be present and only one child will be present. Alright, one master with one child. And the second type of the cluster is that inside the cluster, one master with many child will be present. As you can see that one master with many childs are present. And the third part of the cluster is that the multiple masters with multiple child will be present. Alright, so these are the 3 parts of the cluster that you need to keep in mind. And inside these nodes there are pods. Alright, so I have shown you what is the pod. It is the smallest unit of the Kubernetes. So these are the pods. One node may contain one pod, or one node may contain multiple pods. Alright, so inside these pods there are containers. Alright, so one pod may contain multiple containers, or one pod may contain one container also. Alright, so inside these containers there are multiple applications. So I hope you understood what I have taught you in this video. So what we have learned today, the first one is the monolithic and microservices. The second thing we have learned is the containers and their downsides. The third thing is the Kubernetes and its history. And the fourth thing is the Kubernetes features and its small architecture. Alright, so that's it. I hope you like this video. So if you like this, then make sure to subscribe to my channel. And if you have any questions, then ask those questions in the comment section below. I'll be happy to answer all of them. So till then, goodbye.